All right. Good morning, good afternoon, or whenever you are watching this video. We're going to get started into Session 2. On Session 2, we're looking at approximating the area under a curve. We're going to start doing a thing called a Riemann sum, trapezoidal sums. When we're talking about accumulation of area and things like that, what we're looking at is going underneath this curve right here. I think I'm going to have to back my camera up just a hair. Sorry. Go. We've been talking about how we could find the area of under a curve. We actually did this in our last unit where we found a little bit of area underneath it. But right now we're going to be figuring out what does that actually mean, right? So what is a Riemann sum? Well, it's a way of estimating that area, right? Sometimes under a curve, if it was a rectangular curve, if I had a graph, let's say that we have some graph that does this and this and this and comes down, we could actually find the area of this pretty easy by breaking it up into sections. We got a triangle here, rectangle here, trapezoid here, we got a rectangle here. Oh, yeah, you can see that. And we can just find the area of each one of those pieces. But when it's this curve that we have right here, that makes it a little different. So what we're going to do is we're going to look at different ones. We're going to look at a left hand, a right hand, a midpoint, and a trapezoidal. Now, what's going to happen in this unit is it's going to be a very, very tedious unit is what it's going to be. As in it takes more time to do it. The difficulty is low. The time to do them takes a little bit longer because you're having to find all these little areas, and hopefully you'll start seeing some shortcuts that you'll cut out of it. So today, all I plan on doing is we're going to do the very first page. We're going to be doing page 26. I just want to get a start on it, and then I do recommend maybe trying to do the other ones if you can do pages 27, 28, which you're dealing with a lot of. And then we'll come back and we'll look at, because right now we're just going to be looking at the left-hand Riemann sum with intervals of 2. And the next one on page 27 is a left-hand Riemann sum with a width of 1, and then it goes to a half. So I think you can probably do those. Like I said, it's just going to take more time, but the difficulty level is not real difficult. So here we go. Let's consider for a moment the function f of x equals this right here, negative 1/3 x squared plus 2x plus 5. And you can read that, but I'm reading it off to you. That's this curve right here. Graph the function on the axis provided below. So we've graphed this function. I've already got a graph for you. I even have some points labeled for you. On the interval 1, 7, including those, subdivide the area bounded by the graph of the function and the x-axis. So what we're doing is we're finding how much of this area this takes up right here, between here and the x-axis. All right. Place the upper left-hand vertex of the rectangle on the curve each time, then calculate the area of it. So what it's telling us to do, since it's a left-hand Riemann sum, what we're going to do is Riemann sums are using rectangles. So what we're going to have is have a curve, and we're just going to have these rectangles, and we're going to find the area of these rectangles, and it's going to approximate what the area is under this curve. So you have a couple different ones. You have a left hand, a right hand, a midpoint. Right now we're working on the left hand. So what that means is we're going to go from 1, let me see, slide that up a little bit. I'm going to shift that over so you can see it. Okay. So a left-hand Riemann sum, they said we're going to go from 1 to 7. So here's my starting spot. Here's my ending. I don't care about anything else. All we're looking at is this part right here. So I start at 1, and I'm going to go up until I hit the graph. So right there, because this is the left hand of my rectangle, and we're going to have it with 2 units wide. So here's 1. I'm going to go over 2. Now, I got to build a rectangle, so I'm going to come straight across over 2 units. I drop it down. I'm going to shade that in. All right. So now we got to keep going because we've done from 1 to 3. Now we're going to go 3. Well, I've got to come up. I'm going to go up until I hit the point. I'm going to go over 2 units. Now you're saying, wait a minute, you're going over it. That's because this is approximation. So you can see this was an under approximation here. This one was an over approximation. All right, because I'm going to have more area. And I'm going to shade that part. Okay, and now I come to 5. I'm going to go up until I hit the graph. I'm going to switch out the pen again. I'm going to go up until I hit the graph, which is right here. I'm going to go over 2 units. I'm going to go down. And I'm just finding it So I got to find the area of those three rectangles right there. And that'll be an approximation of this curve under the graph. Now we only do it to the x-axis. Right? So the correct way of writing this, this is what we're doing is we're doing a Riemann sum. So we're going to do the Riemann sum, which is the integration. See, this whole integration tells us the area under the curve also. It's not just the antiderivative, but it tells us the area under the curve of that. So we're going to do the difference from 1 to 7, that's where they bounded it, of f of x dx. All right? Now, I'm not going to have you come up here and do the antiderivative of this right now or anything. All we're doing is we're doing a Riemann sum. So the function was right here, f of x equals negative 1/3 x squared plus 2x plus 5. So this is going to, now it's actually an approximation. I should have put it this way. So I got to find the area from 1 to 7 on this interval. So I got to find the area of these three rectangles. So a rectangle is just length times width. Oops. So the area is going to be length times width of each one of these. All right. So the very first one is going to be, it's 2 units wide. And we got to figure out what the height of it is. Well, the height, students go, well, am I estimating that? No. See, we know what the height is. It's when f of, we just plug in 1 right up here into the function, and that'll tell me my y value. So it's going to be 2 times f of 1 plus, the second rectangle is going to be 2, because that's the width, times the height of it. And this one here we can probably figure out, it looks like it's going to be 8. Well, we're going to see if it works. It's going to be f of 3, because that's where it hits it at, plus 2 times where it hit here, which is going to be f of 5. See, we're not having to estimate that approximation because we actually have a function. We plug that in there, right? So here's my approximation. We're going to have 2f. If I plug in 1, I'm going to end up getting, that's going to be 1 squared times, it's going to be negative 1/3 plus 2 plus 5. So I'm going to get 20/3. Plus 2. F of 3, if I plug a 3 in, where 3 squared is 9. 9 times negative 1/3 is going to be a negative 3. 2 times 3 is going to be 6. So we got negative 3 is 6. It's going to be 3. And plus 5 is 8. That's exactly what we said it was going to be when we looked at the graph right there. But we plugged it in to get an exact value. Plus the last one, which is 2 times f of 5. We plug a 5 in there. And I'm just going to tell you right now, we're going to end up getting 20/3 again. You could put that part in your calculator to find those areas. I have no problem with using your calculator to find those to just speed up the process. But again, you know, on a test on Riemann sums, it may be a part that's no calculator. With the test this year, it's going to be a little different with the doing it from home. I guess they're going to probably allow a calculator on all of it because they're not going to be able to really monitor that. So anyway, cleaning this up, I end up getting 40/3 plus 16 plus 40/3, which is 128/3. And I'm going to go ahead and take that to, I'm going to put that in the calculator, and I'm going to get that's approximately 42.667 units. So the area under this curve right here is 42.667 approximately. All right. You can see that right here, I'm missing some here, but I had extra here and I have extra here. Again, this is called an approximation. All right, it's a Riemann sum approximation. Oh, I apologize. I said I was only going to do the first one, but I think I'm going to go ahead and do the second one real quick, and then I think you guys are going to be able to get to running on this. Maybe do the next one. So now we're going to do a left-hand Riemann sum with the intervals of 1. So remember the last one, we had intervals of 2, which meant our width was going to be 2. So now when we do intervals of 1, I'm going to come over here. Again, I'm doing it from 1 to 7. So I'm going to start. Here's my starting spot. Here's my ending spot. Except for each unit now is going to be 1 wide. So I'm going to go start at 1. I'm going to go up until I hit the graph. Go straight across. I'm going to go down 1 unit. I'm going to just go 1 unit this time. Now I got to start. I got to go at 2 because I'm going to 1 unit intervals. I'm going to go up until I hit the graph, go across, go to 3. You can see why this one's, why I said that I hate to do all these on here, because it's just tedious. Going across, now we can see this one's going to be an overestimate. This little rectangle here is going to be more. So far we've been under the curve. Now we're going to be over the curve. Here at 4, we're going to go up till we hit the curve. I'm going to go over, go straight down. This one's going to be larger also. I'm going to go over 1 unit. Go down. Again, continuing on at 6, we're going to go at where it hits it left, because we're doing the left hand. Go across, go down, and we've already got to 7, and so that one right there is going to be my last one I do. So now, here is my graph that I've drawn here, and now I actually got to find the Riemann sum. So we're going to do the Riemann sum. We're going to do the integral from 1 to 7 of f of x dx. That's my function we're doing. So we're finding the area under the curve. It is going to be approximately, and now I got to find the area of each one. So I have 1, 2, 3, 4, 5, 6 rectangles. Each one of them has a width of 1. So I'm going to have 1 times this one here, which is going to be f of 1, plus the next one is going to be, let me close it up, 1 times f of 2, plus 1 for the next one, times f of 3. The reason we're not skipping now is because they're 1 unit apart. So this one hit at f of 1, this blue one hits at f of 2, this one hits at f of 3. So you kind of start seeing a pattern here. 1 for the width times f of 4, plus 1, I'm going to bring this down to right here. 1 times f of 5, plus 1 times f of 6. And that's as far as we're going to go, because we don't have an f of 7 one. The last rectangle had, the height was f of 6. So we have 1, 2, 3, 4, 5, 6 rectangles. So what is my area of that? We're going through each one. If you work through each one of them, here, hang on, I want to pause real quick. I apologize, I'm stumbling over it. If you'll notice, every one of these, since they all had the same interval, it was 1 times 1 times 1 times 1 times 1. So I can actually rewrite this. If I had the same interval, it's just going to be 1 times, I could pull that 1 out, and I have f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5 plus f of 6. See, what this allows us to do is we do it quicker in our calculator. Remember, you have that little note. I want to pause this, grab my calculator. All right, so guys, on our calculator here, remember, we can come up here into our calculator. I can put this function. I'm going to put negative 1/3 x squared plus 2x plus 5. And now, what I can do is to find my area of this, let the calculator do the work for you there. All right. I don't get me wrong. On a free response, they may give you, in the future, you may have your calculus teacher may give you this, and you'll have to do it by hand. But right now, you have a calculator, and all we're doing is just cutting out, honestly, the pre-algebra stuff, because I can give this problem right here to a 7th grade student that's had some functions, some 8th grade understands a function to plug in, hey, f of 1 means plug in a 1, and they could do this part right here. The calculus is setting it up. The rest of it's some algebra, pre-algebra. So what I'm going to do is I'm going to set this up, and I'll just put 1, open parentheses, and now I'm just going to hit my alpha, y equals, I'm going to go over to y vars, y1, and I want to evaluate that one at 1. Remember how we can do that? Plus alpha 2. All right, and we can just continue going. So we're going to have y1 plus y2. Keep going across there. I wish there was a... Oh, all right. So alpha trace 3, alpha trace. Oops. Let me put a plus in there, don't I? Forgot to do one here too. Second insert. Got to catch your mistakes as you're going. Plus alpha trace 4 plus alpha trace 5. I'm trying to, actually I didn't have to put the parentheses in there. I'm just going to continue doing it this way. Plus alpha trace 6. I was putting the parentheses in there, but I forgot about that. So, and if I've done everything correctly, I have 1 times each one of those added together, or I could write it out this way, 1 times each one. If I'm letting the calculator do the work, I end up getting something that's not correct. What did I mess up on that thing? Y equals 2x plus 5. Second. Oops. See, I could pause this right now and fix it, but I think it's better for you to see me work through my mistakes here. Okay. Okay, I am going to pause because cannot figure out where I messed up on this thing. So let me pause real quick. Okay, I was double checking some stuff, and yes, I do have to put the parentheses in there. Sorry. So each one of the, it's got to be y1 with the parentheses in it. So I'm going to second insert. Well, 1. Second insert parentheses, second insert parentheses, second insert parentheses. I apologize, but hey, that's how we learn, right? Now I forgot. Second insert. I've messed this whole thing up. Might have been faster just to retype it. Okay. 125 over 3. There we go. So what happened was when I didn't put those parentheses around it, it didn't tell, I forgot that it's not telling it to evaluate. It's saying multiply 1 times whatever that value is. Well, since there was variables in there, it automatically gave x, whatever the last stored number was in there. So this is telling it to evaluate it 1, evaluate 2. And it just slipped my mind. I apologize. So 125 over 3, well, 125 divided by 3, give it any decimal, is 41.667. So let's look at that real quick. We had 42.667 here. We had 41.667 here. So we're going to just pause right there. I meant for this only be about a 12-minute video. My mistake got it up to nearly 20 minutes. So that finishes up those two. Maybe for tomorrow or before we get to it, hey, let's take a look at, see if you can do the left-hand one at a half-unit intervals. See if you can figure that one out. All right. And then we'll come back and look at right hand and midpoint. And hopefully those will be faster because what I'll do is I'm just going to set it up, start to write it, pause the video, finish it, and then it'll just pop up. Have a good day.